everyone.
Hi everyone, my name is Ademola Birunke. This is a presentation on relational database and GIS. The narrow objective of this project is to establish or to show how relational database can be created using SQLite, and for the geospatial analysis, how GeoPanda can help to do that. This is a project performed by myself and two of my colleagues, Vandan Gadia and Sahar Santo. So
Some of
some
the
of the
basic
basic objectives of this project is to identify, where we're going to get the data from, identify the hydraulic unit areas as well as their codes for watershed and surface water um, for southeast Texas counties. Um, there are 14 of them. We also, of course, collect necessary data from relevant websites, and we are able to develop a relational database between a couple of the tables that were established for the several data sets that we obtained for this project.
we're able to
We were able to identify the three um, hydraulic unit areas around those 14 counties. And so the ARC8 areas are the broader layer of watershed around those 14 counties. Up 10 is uh, the second layer, which is a bit narrower in terms of the size of the watershed around those 14 counties, and the up 12 hydraulic units are water surfaces that are the most basic around those 14 counties of southeast Texas.
so
So a relational database is just a database that has at least two tables. In many cases, they have several tables, and for this project, we actually have several tables. But we were able to establish relationships between a couple of those tables, and so for as I'm showing on this slide right now, these are two of the tables that were created for this project. One table is for the peak flow of surface water at several sites in those 14 counties of Southeast Texas. And there's another table that was created for the location of the sites or stations in which this surface water and watershed data were being captured. For the peak flow table, the site number as well as the peak dates were used as a primary keys in order to provide unique combination of keys. And this is so because the site number, which would have been a good primary key, is being repeated for the peak flow data. So for that purpose of that particular column not having unique values, there has to be another column that we combined with that column to provide the primary key for that table. For the location data table, the primary key is the serial number, and the foreign key is a site number, and that's how we're able to establish relationship between these two tables. So the primary key for the peak flow date table is a foreign key for location table. This project, although may be considered a mini project, is data intensive. There was a lot of data collected for this project. It is still ongoing actually, but for the purpose of this presentation, this is just to show some of the to show how the data that was being collected was being tracked to make sure that there's accountability and there's a record of how the data was being captured, what kind of data it was, the date it was being captured, the areas or the counties for which the data was being captured, um, the URL links of some of the websites in which, or all the websites in which data was being captured from, and location of storage of this of the data. Some of the challenges that were encountered in the course of this project include data collection. A significant amount of time was spent trying to identify the correct data. And then as soon as the data was being collected, it had to be cleaned, because not every part of the data that were collected was useful for the purpose of this project, and so a significant amount of time was dedicated to refining and cleaning the data. And as soon as that was done, the other challenge that we had was to be able to establish relationships between each of the tables that was created in the course of this project. And like I said earlier, this is still an ongoing project. We've been able to achieve a significant part of our objectives, but some of the tables are, as this kind of relationship we want to establish for some of the tables are not being established yet. Although we've been able to achieve, connecting some of the tables, and so some of the challenges that we had while establishing these relationships, is to be able to obtain to write the codes in such a way that the tables can be connected in the database. And so some of the codes, we had some challenges with writing, proper codes. So I'm going to jump into the the Jupyter notebook to explain some part of this project, but I'd like to summarize just, some the aim and what we've been able to do on this project. So one of the things that we found in the course of this project is that relational database enables faster and more efficient management of data handling. And we also saw that the bigger the data, the more useful Python language and libraries like SQLite are for analyzing, modeling, testing, and training data.
Thank you, Adimullah, for your great presentation in PowerPoint. I'm going to present from here a relational database for Southeast Texas, watershed, and surface water. This is our project, watershed and surface water resource of Southeast Texas. We're going to load libraries. We're going to import the SQLite for relational database, Panda, then NumPy and GeoPanda, and change the working directory and read data from the separate value CVS file, location data from 14 countries CVS file, and we have peak flow, annual peak flow like 100 years. So name of the CVS file peak flow. After that, we have steam flow for 50 years. We split it 10 years. Then we are going to start from 1972 to 1982. After that, we will keep going like that, and we will end like 2012 to 2022. And when we after that, we made some mistakes, so we have to delete some table. So we are going to to drop a table, to drop table name, and then after that we are going to create a data that create a table create a table. So first of all, we are going to create a table for location. After that, we are going to create a table for a peak steam flow, and like that we have like Hawk 12. We're going to create a table for Hawk 12 and same age like steam flow for sorry so for peak steam flow non-country 1922 to 2012 create a surface water daily steam flow. Now we are going to create a surface uh, we are going to create a table for surface water daily steam flow. It will be like 1972 to 1982. Before I told like we are going to split it 10 years. So we are keep going like before. So we are going to create a table from like 1972 to 1982 and like same like 1982 to 1992 and we keep go like until 2012 to 2022. We create a mat data. Um, that's it. After that, like from insert values into table in database, my colleague Bandhan, he's going to his presentation. Thank you.
You, Ovi, for explaining the remaining part. From now, I will explain how to insert the value in the table in database. So now we created tables, and now it is time to insert the value in the table. So now by typing this code, we can insert the values by running a for loop into that. Then same with the Hug12 table. Then we can so this is how our relational database is created. Now we can query our database. So for the first query is like we are trying to derive the peak stream flow. We are trying to extract the peak stream flow from our database, and we successfully did that, and we get the results for that, and we run the second query that the Hug12 where feed is equal to 5. We are trying to extract this data from our database, and we successfully did it. So this is the result for that. So it is the part where we create the relational database and run a successful queries. Now our part is to plot the maps. So for plotting the maps, we have to we have one county shapefile of Texas. So we created a geodata frame using GeoPandas and plot the Texas counties map. Then we have to separate. We are performing the site locations for the Southeast Texas counties. So now we have to separate these 14 counties from the Texas county map. So by this code, we can create we can create just 14 counties map, which is here. The result is here. Then we have another shapefile that is a HUC8, which is representing the HUC8 subbasins. So we plot that file, we convert into geodata frame and plot that file. Then we want to clip this counties into the HUC8. So we can see the HUC8 of the South Texas counties. But if we gonna clip this, we can using clip, but they both have the same. They both should have same CRS. So for the HUC8, we check the CRS. Here is EPSG 4269 NAD83, and for the counties that is the 4326. So we have to convert this county sets CRS to the same as NAD83. So with the HUC8, so we converted both CRS to the EPSG 4269, which is NAD83. Now we can, if we check the HUC8 CRS is 4269 NAD83, and the other CRS is NAD83. Other county set CRS also NAD83. Now we can clip SETx Southeast Texas counties and HUC8 map. So it is look like this. By using the clip function, we can clip the 2D shape files, and this is the results for that. Now we will create the site location map. So for the site location map, we have latitude and longitude in the one CSV file. So we have to make the geometry column out of it. So for the geometry column, we can use the shape point function from the shapely.geometry. So we converted into pandas. We converted our CSV file into the pandas data frame. Then we create the geometric column, and we create the geodata frame out of that. Then we plot the then we gonna plot the site locations over the Texas map, over the Southeast Texas map. So this is how it's look like. This pink, this magenta rounds are the site location over the Southeast Texas map. So as of now, we are able to do this, but we further we can show the locations of other surface resources and different datas like peak flow, daily stream flow, then hydrology data, and many more datas. We can create a 3D map out of it, or the static map out of it, and we can uh, we can plot any data into this kind of map. So thank you. This is our presentation. So thank you for watching our video. Thank you.